Grade 5 pupils, looking at some questions at how the discriminant can be used. So straight into two examples. In first example, find the values of p such that we're given a quadratic with a constant value missing, so that p has real roots. So what we can say here is, from our knowledge of the discriminant, which we've looked at in the previous part of the note, three different options. Real roots, we have b squared minus 4ac is greater than 0, would represent real roots, but also b squared minus 4ac would equal to 0, would represent real roots. So what we can say, we can make an opening statement that for our quadratic, x squared minus 2x plus p to equal 0 to have real roots, then b squared minus 4ac must be not just greater than, but equal also to 0. So that statement is taken from all the information that we've got. So if we create an equation, substituting in b squared, b values, a, b and c values, then we'll be able to work out the missing value for p. So we have an a value of 1, coefficient of x squared, a b value of minus 2, coefficient of x, and our constant value unknown, but it is p. So we're not just saying that discriminant to start our working here, we can say that the discriminant is greater than or equal to 0. And it's a case of substituting and then solving our inequation. B value is negative 2, 4 times 1 times p, and that's greater than or equal to 0. 4 minus 4p greater than or equal to 0. Let's take our time solving. So adding 4p to both sides means that 4 is greater than or equal to 4p. Let's divide both sides by 4 to get a single p value. 1 is greater than or equal to p. So if 1 is greater than or equal to p, let's reverse that statement. And therefore p must be less than or equal to 1. So what we're saying is, for that quadratic to have real roots, the p value is less than or equal to 1. So let's communicate that. For our quadratic stated in the question, b equal to 0 to have real roots, our p value is less than or equal to 1. Okay, so taking the information very carefully from the first part of the question. In 2, set the values of p such that, again we've got a quadratic, this time the p appears in two different places, has equal roots. So equal roots is a single statement. b squared minus 4ac is equal to 0. So there's nothing else that would provide our equal roots. So let's communicate that. For our quadratic, equals 0 to have the equal roots, our discriminant must equal to 0. So again, that will give us a starting point for our calculation. So let's look at our coefficients here. So I can easily take out the x squared, I can easily take out the 6x. That there, the p minus 2 is my full constant. Whatever my p value is, minus 2 will give me a constant value. So A is 3p, B is minus 6, and C is p minus 2. Okay, there's my opening statement. P squared minus 4ac is equal to 0. Minus 4 times 3p times by that full bracket is equal to 0. Let's take our time. 36. 4 lots of 3p is 12p. P minus 2 is equal to 0. So 36 minus 12p squared plus 24 lots of p is equal to 0. I'm going to go for descending powers of x. Plus 24p plus 36 is equal to 0. And I've currently got a negative p squared value. So two options, either add all the terms onto both sides and I end up with 0 equals my quadratic, or times everything by -1. 0 lots of -1 is still 0. And then end up with a positive. Should be negative there. Sum that. Okay, and no surprises here. I've got a quadratic, it's equal to 0. I want to try and find my p value. So I'm going to factorise and solve. Nice common factor would be taken out. No common factor, no difference of two squares. The only way I can get p squared is p and p. The only way I can get 3 is 3 and 1. And there's my two middle terms, or my two multiplications to get my middle terms. And therefore the way I can get minus 2p is with the minus 3 plus 1. So to solve, the only way that this can equal to 0 would be if p minus 3 was equal to 0, i.e. p is equal to 3, or if p plus 1 is equal to 0, p is equal to minus 1. So that's the information that I need. So what I'm saying is, for equal roots to occur, two options for p is equal to 3 or p is equal to minus 1. So communicating that, for quadratic, 3px squared minus 6x plus p minus 2 to equal 0. To have equal roots, so for that to happen, that p value must equal to 3, or the p value is equal to minus 1. And as always, at this stage, we're looking at the burn point for the questions to attempt.